Okay, so now we are getting into AWS Lambda, and going into the exam, there's a lot of details you need to know about the AWS Lambda. So you don't need to be a developer, but you really need to know the details of how Lambda works to pass the certified solution architect professional exam. So the main integration of Lambda is going to be, we will be starting here with the integration. So main integration of the Lambda is going to be the API gateway, Kinesis, DynamoDB, S3, IoT, CloudWatch events, CloudWatch logs, SNS, Cognito, and SQS. You may be able to see that right now. I'm not sure. So these things you should know that this should be pretty natural. Lambda is going to be used to do a lot of automation, to do a lot of event processing, and to react to things happening in your infrastructure. So these integrations should make sense to you by now. And let's get through an example. So that is the serverless thumbnail creation. So here, where we have a new image inserted into S3, S3 will trigger a Lambda function. That Lambda function will create a thumbnail of that image, maybe push it into another S3 bucket, and also push some metadata in DynamoDB, such as the image name, image size, creation date, image path, and etc. etc. So this was an example of serverless thumbnail creation with the AWS Lambda through the trigger from the S3. So another very common use for Lambda is serverless cron jobs. So instead of having a cron server on EC2 machine, which may cost you a lot of money because the EC2 machine doesn't do much most of the time, you can define a CloudWatch event, and that CloudWatch event can be triggered every X number of hours. For example, every 1 hour, and trigger an AWS Lambda function that will perform a quick task up to 15 minutes. So the highest limit is of 15 minutes. So this would be, it's starting from, I think, 0 seconds or 15 minutes or 15 minutes. So this would be a great way to do serverless cron job, because we don't manage any infrastructure. CloudWatch events is serverless, and so is AWS Lambda. So AWS Lambda has a lot of language supports or runtimes. Okay, so we have Node.js for JavaScript, we have Python, we have Java, we have C Sharp, we have .NET Core, or Golang, C Sharp, or PowerShell, Ruby, and you have a custom runtime API which allow you to get, for example, some community supported runtime such as Rust. There's also a feature of Lambda called the Lambda container image, which allow you to get containers onto Lambda, but the container image cannot be any kind of image. It must implement the Lambda runtime API. So if you want to run an arbitrary Docker image, then the preferred way is to still use the ACS and Fargate containers. Now, I'm sorry for this delay. I am just checking the status of the recording. Now for limits, to know on Lambda, well, the RAM can go up to the 128 megabytes to 10 gigabytes. 128 megabyte to 10 gigabytes. The CPU is going to be linked to RAM, and the more RAM you get, the more CPU you have. So you have two virtual CPUs at 1769 megabyte of RAM, and 6 virtual CPUs when you have 10 gigabytes of RAM. Okay, 10 gigabyte, 6 virtual CPU, and 1 point or around 2 gigabyte of RAM, 2 virtual CPUs. So this increases simultaneously. The timeout is up to 15 minutes. The temporary storage is 512 megabytes, so you cannot process big files. The package itself zipped has 50 megabyte limits and 250 megabytes unzipped, including the Lambda layers also. So you can have around you can have up to 1,000 concurrent executions of Lambda function, and it's a soft limit that can be increased. The max container image size is of 10 gigabytes, and the invocation payload is for synchronous use cases 6 megabytes. So, and for asynchronous use cases 256 kilobyte. For the synchronous we have 6 megabyte, and for the asynchronous we have 256 kilobyte. Yeah, that makes sense. Now, great. So now let's talk about the Lambda latency consideration. So Lambda latency consideration is just a high level of discussion, but assume you have something like this, but where you have an API gateway that can be invoked using the REST API and is going to proxy the request to a Lambda function. Now the Lambda function, you have been evolving in the microservice type of architecture, and someone has told you, well, you need to talk to another service. One may be front end by API gateway, and maybe other one is front end by CloudFront. Maybe the third one is front end by ELB, Elastic Load Balancer. And so you are adding some API calls over the network, and that adds latency. So just to give you some approximates of latency, just you can realize how much latency will add. So a cold Lambda invocation, so that means when your Lambda is not already started and not already warm, will cost you about 100 milliseconds, and these are approximate. So if you have different numbers, it's just to illustrate a point. Okay, if your Lambda is already warm, though that means that it's already invoked once and the Lambda container is already ready, then it's just a matter of millisecond. Now there's a feature as of the December 2019 to reduce the number of cold starts you are having, called provision concurrency. So where AWS will try to keep a small amount of Lambda that you choose already warm, so that if you invoke them, they don't have that 100 millisecond cold Lambda invocation start latency. Now whenever you go through an API gateway, you should add about 100 millisecond of invocation time also. Same for the CloudFront. So if you start chaining stuff with other services, so if you start chaining API gateway, CloudFront, application load balancer, Lambda, maybe an SQS, so step functions, so you need to add all the latencies of these things all together. And the idea is that the more you start chain calls, the more will add latency. And if you have something that needs to respond in the less than 300 millisecond, then and you need to change all these calls, it will not work. The only way to do is to have everything processed in one Lambda function and forget about this multi-layer architecture. Again, read the requirements and make sure your decision makes your decisions. Finally, X-ray is a tool that can help you visualize the end-to-end latency of your architecture. So it's really helpful for debugging. Okay, this is where I lost most of the time, and this is where I'm losing a lot of processing power. This is where I am waiting for the network calls and X-ray. So the X-ray is a great tool to debug and tracing the whole network stack and call stack of your functions and API calls. Cool. Now let's get into the Lambda security. So IAM roles for Lambda are extremely important, but we already know this, and they allow your Lambda function to talk to other AWS services. For example, if your Lambda function was doing write to DynamoDB, and it would need IAM role that provide access to DynamoDB. Now there's another thing that you may not know, called the resource-based policy for the Lambda. This is very similar to S3 bucket policy, and the idea is that you define a policy in JSON, and if you look at this one, it says that it's allowing the principal service SNS to invoke your Lambda function, and the resource is the Lambda function, whatever. So the idea here is that the resource policy allows SNS to invoke our Lambda function, and that makes sense whenever a Lambda function is invoked. By SNS, you need to have some kind of security in place to make sure that yes, it is possible. So behind the scenes, when you connect SNS to Lambda function, a resource-based policy gets created. So it's really important to know this because it's not something that's widely known and that may be necessary for the exam. So these resource-based policy can do two things. They can allow other accounts to invoke or manage Lambda. So if we have a cross-account access of Lambda, we could define a resource-based policy allowing another account to access our Lambda function, or allow other services such as SNS and other to invoke or manage our Lambda function. So very, very important. Going into the security. Now, another kind of the security, which is be the VPC in a network security. So let's talk about the Lambda in a VPC, because that is a deployment option that is the possible for the AWS Lambda. The first one is that when you have a default Lambda deployment out of a VPC, the Lambda function sits within the AWS cloud, so it can definitely talk to external APIs through the public internet. That makes sense, and it can even talk to services such as DynamoDB, because DynamoDB has a public endpoint and so it is accessible directly from Lambda. But if you have a VPC and within the VPC you have a private subnet, so a RDS database, for example, that is only accessible through a private IP, then your Lambda function cannot access your RDS database. And this is not working. There will be no network routes between the AWS cloud and your RDS database. The solution to that is to obviously launch your Lambda within your VPC. So now we have Lambda within our VPC, and because it is within our VPC, it gets an elastic network interface ENI and needs to assign a security group. So Lambda will have a security group assigned, and now this looks just like an EC2 instance. Just like an EC2 instance, we can talk to a private RDS by allowing the Lambda security group into the RDS security group. But now we have another problem. What is that, right? Because our Lambda function is in our private subnets, but now it's trying to access the same external API from before. The issue is that it is in a private subnet. So the only way and and we have seen this from other courses is that the access to the external API you need to go through and NAT gateway or NAT instance that is placed in the public subnet, and then NAT instance needs to be connected to an internet gateway in the public subnet to talk to your external API. So this is the way and it works. Now let's talk about talking to DynamoDB. So to talk to DynamoDB, we can go to the exact same route. We can go through the NAT instance and the NAT gateway, talk to the internet gateway, and from the internet gateway talk to DynamoDB. So this will definitely work, although you will incur cost because the data will be going through the public internet and the NAT instance or gateway are expensive, and so the internet gateway. So it may not be most efficient solution, but it will definitely work. A better solution would be to use a VPC endpoint gateway for DynamoDB, in which case the endpoint will provide you a private access route to DynamoDB from your private subnets, and so you lend the function thanks to the route tables, and you will have the defined can automatically go to the VPC endpoint gateway and talk to DynamoDB. So this is the two kind of architectures you need to remember, because if you have a question about Lambda deployment in a VPC, you really need to understand all the networking implications of this and all the possibilities you have for you to achieve the best solution. Note that your Lambda, whether or not it is deployed in your VPC or out of your VPC or CloudWatch logs, it will work no matter what. So CloudWatch logs is something that's provided by AWS Cloud for you. So no matter what, your Lambda function will be able to send its logs to CloudWatch logs, because CloudWatch logs should be pulling these logs from the Lambda internally. Okay, so no need to worry about the networking for that one little feature. Okay. finally, let's talk about the logging, monitoring, and tracing. So we know there's a CloudWatch and the Lambda integration, okay? And the first one is that the Lambda execution logs will be stored in the CloudWatch logs, no matter what, if it's in your VPC, out of your VPC, it's in the private subnet. And we also get CloudWatch metrics that represent successful invocation, error rates, latencies, timeouts, and etc. etc. For CloudWatch invocation to work through, you need to make sure your AWS Lambda function has an IAM policy and IAM role that authorizes writes to the CloudWatch logs. It's very important. Next we have X-ray and X-rays for distributed tracing. X-rays and X-rays for distributed tracing. So it is possible to trace Lambda functions with X-ray. So this you just need to enable it in the Lambda configuration, and then AWS will run the X-ray daemon for you, or we can use the AWS SDK in the code as well to add some X-ray pointers. And finally, obviously, you need to ensure that your Lambda function has the correct IAM execution role to talk to X-ray. Okay, so that's it for the like logging, monitoring, and tracing on the AWS Lambda. Now let's get into the more details for Lambda. So Lambda has three kinds of invocations. Synchronous invocations, asynchronous invocations, and the third one is, we'll be seeing further, don't worry about that. And the third one is event source mapping. We'll be starting with the synchronous invocation. So the synchronous invocation, that means whether when you use the CLI, the SDK, or the API gateway, you will be in a synchronous kind of invocation. That means that results will be returned to you right away synchronously. So your code will be waiting for the results. So if there is an error handling that needs to be that needs to happen, it needs to happen on your side, client side. That means that if your Lambda function doesn't function correctly, if you want to retry, it's up to you. If you want to retry with exponential backoff, so I mean wait a little bit more before you retry again, like it's goes through the 5 millisecond, then 10 millisecond, then 20 millisecond, then 40 millisecond, then 80 millisecond, somewhat this up to like even it goes up to the 3 minutes or something. So so this is the exponential retry with the exponential backoff, retry again. So it's up to you. So the second example, your SDK has a Lambda function. You are going to invoke it. The Lambda function will do something, and then you will wait for the response. And the response is not what you expect, and you want to re-invoke it on the function. And this is up to you. Similarly, if you go through an API gateway and the clients invoke the REST API, the API gateway will proxy the request to learn the function. To run the function, which will do something, okay, then returns a response to the API gateway. And then you will be waiting for the response from the API gateway, and that is again a synchronous invocation. And so in case there is anything that goes wrong in the invocation, and it's up to you to handle the failures and make sure that you get the right results that you want. The second kind of invocation is called an asynchronous invocation. That is when the advanced source is S3, SNS, or CloudWatch events. So in this case, Lambda will attempt to retry on errors with 3 tries in total. That means that if you can't process, for example, a thumbnail coming from S3, for whatever reason, then Lambda will retry it 3 times. So you need to make sure that the processing is idempotent. Okay, idempotent. That's really important, because if your Lambda function retries something and, for example, does some changes to database every time it retries, if the processing is not idempotent, that means if the processing when it's done twice will do the effect twice. That means you may have some side effects that you are not expecting. Okay, so making sure your processing is idempotent is really important. So here's an example. We get a new file in S3 and it will trigger the Lambda function. So that is an asynchronous type of invocation. Your Lambda function can do some retries, and so in case all the retry fail, you can define something called DLQ, dead letter queue, which can have SNS topics or SQS queues as a target for any failed processed events. So as an optional thing, your Lambda function after all the retries, instead of just discarding the events, can send the event to a dead letter queue, DLQ, for example SQS in this example. So this is the second type of invocation. Another kind of processing for Lambda is event source mapping, and these is applicable to source such as Kinesis data streams, SQS, SQS FIFO, DynamoDB streams, Amazon MQ, and Apache Kafka. So this is the kind Apache Kafka is similar to the Kinesis data streams. So the common denominator, so Kinesis data stream is built on the Apache Kafka. So the common denominator between all these sources is that the records needs to be pulled from the source and then processed. And so for all these sources, Lambda is going to say, hey, give me the next batch of data, and retrieve it. Okay. Now for all the records are going to be processed in order for these sources and respect the ordering properties, except for the SQS standard, which, as you know, does not have any kind of ordering guarantees. So does that work? So we have the sources that I just mentioned, the 6 of them, and then we have the Lambda function, and in between we have a Lambda event source mapping. So this is something internal within AWS, that we are going to pull the messages from the sources, retrieve batches from them, and with this batch is going to invoke our Lambda function. Now if the function returns an error, the entire batch is going to be reprocessed until success. Okay, and in case of Kinesis DynamoDB stream, the SARD is going to be stopped for processing. For SQS FIFO, it's going to stop unless you define an SQS DLQ, and then at some point the message will go into the DLQ for SQS, and that means that overall, because the Lambda function can retry some messages, it needs to make sure that the processing of your Lambda is idempotent. That means that if you see the same message twice, you don't have adverse effects running the function again. Now something a bit more new, which is coming from November 2019, which is that you can configure your Lambda function to send results to something called a destination, and that is valid for both asynchronous invocations and event source mapping. So let's go ahead and talk about that in detail. For asynchronous invocation, you can define a destination for successful and failed events. So the idea right now is that if you don't define a destination and your Lambda function returns something, that something is just completely ignored. So instead, you can say, okay, that something can be sent to Amazon SQS, Amazon SNS, another Lambda function, or an event bridge bus. So the idea here is that, okay, the the Lambda function will process events from the event queue asynchronously, and if it returns to something successful, we can define a successful destination. For example, again, SQS, SNS, Lambda, and so on. Or if we have failed records, we can also send these records to a failed events destination. So we have two kinds of destinations: successful events and failed event destination. So if you are following me, you may be saying, okay, you just told me about DLQs, okay, dead letter queues. Now you are telling me about destinations. So yes, destinations for failed events and DLQs are very similar, but now AWS recommends that you use destination instead of dead letter queue. In the future, for Lambda function that are asynchronous, but both can be used at the same time. And yes, there is some overlapping feature, but the idea is that with destination, you have more destinations. With a DLQ, you just have a SNS and SQS, but with destination, you can also send it to a Lambda and to an event bridge bus. Next, for event source mapping, it's only going to be a destination for discarded event batches. Okay, so only for the failures, and this can be sent to SQS and SNS. So here's the diagram have been given, and you can see in the slide. We are reading records from the kinesis, and the event source mapping will send it to the Lambda function. And the bottom one diagram will send it to the Lambda function. It's under the Lambda function. Okay, let me see the diagram a little one more time. But in case here, if we are failing to process these records, we have the option to send them into SQS and SNS as a failed event destination, and then we can keep on going with our Amazon Kinesis data stream processing. So it's a way for us to be unlocked from a lockdown in case we cannot process some records. So here to note though is that in case we are processing stuff from SQS queue, we can also create a dead letter queue directly from SQS as an alternative. So again, as a solution architect, there's not only one way of doing things. It's up to you to choose the best way for your requirements in understanding what your requirements are in the first place. Okay, now let's move to a little bit more, a little bit from how Lambda processes things to Lambda versions. So when you create the work on the Lambda function, create and work on the Lambda function, you always work on something called latest version, okay, which is the latest version. Okay, it's a mutable function because you can modify it, but when you are ready and you want to publish the Lambda function, you create a version. So the v1, for example, so it's the first version you would create that would be immutable. Okay, that means that you cannot modify it, so any versions is immutable. So as soon as you say I publish a Lambda function, it set in stone, this is how it will be published. The versions will have increasing numbers. So after v1 you will have the v2 and so on, and so each version will get its own ARN, so Amazon resource name. So that means you can invoke separately v1 or you can invoke separately v2. You can invoke $latest, so the latest version of the Lambda function. So the version, what is it? So it's the code as the time you are publishing it, and the configuration. So the environment variables, the CPU, the RAM, etc., and nothing can be changed. It's immutable. Okay. So if you if you wanted to change the CPU or change the RAM, you need to create a new version and publish that as a v2. So each version of the Lambda function can be accessed, and that's really helpful when you are doing some canary testing. Now let's talk about thing which is Lambda Aliases. So aliases are pointers to AWS Lambda functions versions, and you can define, for example, whatever alias you want, but some very common alias is going to be dev, test, and prod aliases, and then these aliases can point to different Lambda versions. The good thing is that aliases are mutable, so you can change how alias work. So let's take an example. We have a $latest function here. You have $latest function v1 and v2, which is from the previous example, and we are going to create. So this one, that one is being done by me, is the v2 immutable. So we are going to create a dev alias, which is mutable, which is going to point always to the $latest Lambda function we have. And so when the users talk to our dev alias, which has its own ARN as well, and they will be redirected to the $latest lambda function. For the test alias, which is also immutable, which is also immutable, we can point to the v2 of our lambda function, and so when our users talk to our test alias, they will get to the v2. And finally, our production alias can be prod alias can be pointing to v1. The good thing is that from a user facing perspective, we can have dev, test, and prod aliases, and then we can mutate these alias to point to whatever lambda functions we want. So aliases enable blue or green deployments because we can assign weights to the lambda function. So instead of replying to one lambda function, it's possible for prod, for example, to be pointing 95% of the traffic to v1 and 5% of the traffic to the v2 to test how it's reacting. Okay, so now the aliases enables stable configuration. For example, at the API gateway level. So as we'll see in the next slide, the aliases have their own ARN. So how does it go with the API gateway? So we have a dev stage and pointing it to dev alias, which is one pointing 100% of its traffic to the $latest lambda function. Then we have a test stage pointing to the test alias, pointing to 100% of its traffic to the v2 lambda function. And then we have production stage, same thing right now, pointing to the v1 function of our lambda function, and it's 100% of the traffic. But in case we want to start slowly introducing v2 into the production alias, what we can do is point 95% of the traffic to v1 and the 5% of the traffic to v2. So in this example, what I can see, what I want you to notice is that the changes happen at the lambda alias level. Okay, the changes happen at the lambda alias level. But from an API gateway perspective, there are no changes, so we don't have to reconfigure our API gateway. If it's pointing to an alias on lambda, and if we want to make our lambda functions to backend evolved, the only thing we have to do is to create new versions of our lambda function and make sure that the alias are slowly pointing to the new versions of our lambda function. So very important to understand this distinction. There's a difference between the API gateway changes and the lambda functions and alias version changes. Next, finally, lambda and code deploy. So good code deploy can help you automate this traffic shift feature for your lambda aliases, and the feature is directly integrated. So if you are using the serverless application model or SAM framework, the idea is you have the prod alias and it's pointing to v1 and v2, and you want to slowly shift from v1 to v2. So at the first you have 100% on v1 and 0% on v2, and you want to start introducing a minus x on v1 and plus x on v2 to shift the percentage slowly and gradually. So code deploy will be helping you, and it will make the little x in my diagram vary over time until x becomes 100%. Okay, good, that's a good thing. And so when it's 100%, then if you make the math, 100 minus 100 will be v1 equals 0%, so no traffic on v1, and v2 will have the 100% of the traffic. Okay, so what are the strategies to make this x vary over time? The first one is linear, where you grow traffic every n minutes until 100%. So the x will gonna be like 5% and then 10%, then 15%, 20%, and so on. So you have some strategies that are very obvious, for example, called linear 10% every 3 minutes. That means that you will get 10% increase of traffic every 3 minutes, or linear 10% every 10 minutes. So you have different strategies, and you can define your own also. And there's a canary where you try x% of for like a few amounts of time, and then you switch to 100%. So it's a two-step thing. So you can get candidate 10% 5 minutes. So that means for 5 minutes 10% of the traffic will go to the new version, and if we don't get any error, everything will go to the new version. But if but you can have candidate 10% 30 minutes if you want to be more cautious, and then you have all at once, which is immediate. So we don't even have the X value, okay? We just migrated from V1 to V2 right away. So the good thing is that you can check the health of your Lambda function as code deploy migrates from the V1 to V2. So the thing is that is you can create a pre and post traffic hook to check the health of the Lambda function. So when you first deploy a new Lambda function, you create a pre-traffic hook. You create a pre-traffic hook to make sure it's working, and then when everything is shifted to the new Lambda function, you can create a post-traffic hook, which is health check again to make sure everything is working. And that could be really helpful to do the automated rollback in case anything goes wrong. All right, so that's it for this long lecture. I hope you liked it, and I will see you in the next lecture.